Alright, so I am recording this lesson so that those of you who need a little bit of extra practice with exponents can do so on your own time. You can watch this as many times as you need it, pause it, rewind it, and just make sure you walk away with a good understanding of exponents and how they work and just feeling comfortable solving problems that involve exponents. So let's get right to it. This looks very similar to the lesson that we went over in class. We're going to add a few more examples to that and just walk through it a little slower. So again, exponents. We use them as a way to represent numbers. This is the exact example that we used in class, 5 to the fourth power. So first let's define a couple things related to exponents. The first thing that you're going to want is, what are these two numbers referring to? The 4, the little tiny guy, is your exponent, and the 5 in this example is known as the base. And all that you're doing with exponents is the exponent tells you how many times the base is going to be multiplied by itself. So in this example, our 4 is how many times we are going to multiply the 5 by itself. So if we expand this out, 5 to the fourth power is just 5 times 5 times 5 times 5, which is just 625. So a couple things to be careful of. What is 5 to the fourth power not? 5 to the fourth power is not 5 times 4. Be careful. Like I said, a lot of times people try to whiz through these problems. They look, oh, 5 to the fourth power, 5 times 4 is 20. They move on, but be careful. Exponent tells you how many times to multiply the base by itself. So 5 times 5 times 5 times 5, 625. And that's that. So let's look at a couple of examples. Because the more you practice, the better you're going to get at this and the more comfortable you will feel with it all. So these were the problems that we looked at in class, but it can't hurt to look at them one more time. I want you to be able to take a set of exponents, or a set of numbers, and put them in exponential form, which is what we're going to do now, but then also the opposite of that, take something that's in exponential form and expand it out. So these, just ask yourself, what's the base? What's the number that I'm using as the factor to multiply by itself? In this one, 3 and 94 hundredths is my base. How many times am I multiplying it by itself? Twice. And there's my exponent, 3.94, 3 and 94 hundredths to the second power. The base is 3 and 94 hundredths. The exponent is 2. All right, let's look at the next one. 7 times 7 times 7 times 7. If I'm writing that in exponential form, my base is 7. How many times am I multiplying it by itself? 1, 2, 3, 4. 4 times. So there's my exponent, 7 to the fourth power. And my last one here, we're using a set of variables now, but same concept. Don't let the fact that it's a variable throw you. The base is x. That's how many times. That's the thing being multiplied, excuse me. And how many times am I multiplying it by itself? 1, 2, 3. That's my exponent. X to the third power. X is the base. 3 is the exponent. All right, so let's look at a few more examples that we didn't see in class before. Write each expression using an exponent. Okay, we can do that. If you'd like, pause the video for a second, write these 3 down on your own, and give them a try. And then when you unpause, you can make sure that you're right. So if you tried them on your own, your first one, your base is 2.5, 2 and 5 tenths. And the exponent, 1, 2, 3 by itself. There you go. 2 and 5 tenths to the third power. Next one, got a set of variables. So my base is b, 1, 2, 3, 4, 5. B to the fifth power. And in this last one, we've got 2 separate things, so be careful. Here's one base, 25. There's only one, so you could put to the first power, or you could just leave it as is, times, I have another base, n, and it's being multiplied by itself 4 times, so that's n to the 4th power. So again, when you're writing these out, when you're taking an expression, putting it in exponential form, base to however many times it's being multiplied by itself. We looked at one in class where I tried to trip you up, and I did a number added together. Just because I have the same number being added together does not mean exponential form. Exponents are when you're multiplying a factor by itself, not adding. So this would not be written in exponential form. Let's look at a few more. Okay. Here we're going the other way. Simplify each expression. These are in exponential form. So what I'd like you to be able to do is expand this out and then also find the final answer if you were to multiply it correctly. So again, pause the video if you want, and then unpause and see if you can come up with the right answer. So this first one would expand out to 4 times 4 times 4. My base is 4, that's the number being multiplied. 3 is the exponent, that's how many times I am multiplying it. And if you do your math properly, you should get 4 times 4 times 4 is 64. All right, let's look at the next one. So now we're dealing with something that's more than one step. All right, so you need to think order of operations, PEMDAS, or please excuse my dear Aunt Sally, whatever you use to remember it. So the first step for this is I need to figure out what my base is. So I'm going to solve in the parentheses first. Parentheses comes before exponent. So 2 plus 3 is 5. My exponent is 2. And if I expand that out, one more step, 5 times 5, which is 25. All right, let's do 2 more. This right here, I'd like you to take your time. First, I've got parentheses, so I'm going to deal with the parentheses first. Within the parentheses, I have an exponent. So exponents comes before anything else. So let's break this down. 3 to the 2nd power is just 3 times 3. So let's work this out over here. So 3 times 3 is 9 minus 1, which you might have been able to do in your head in one step, but just so we can visualize what we're doing. So then next step, finish the parentheses. 9 minus 1 is 8 squared, or to the 2nd power, which can be written out as 8 times 8, which if you know your facts, very simple, 64. And the last one I realized I hadn't written out, but that's because I wanted you to look at one that has something a little bit different. Okay. Just because I've got a fraction doesn't mean anything changes. The base in this one, instead of a whole number, is a fraction. It's 1/3. And the exponent is 3. So what is that going to look like? 1/3 times itself 3 times. And if you can think back to last year, or any prior years where you multiplied or added or whatever with fractions, when you multiply your numerators across, so 1 times 1 times 1 is 1, and then 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27. So 1/3 to the 3rd power follows the same set of rules, 1/27. All right. And I feel like it's always good just to look at one of these as a word problem. So the last thing is let's just see it in a word problem. A lot of times that you deal with exponents in the real world is in science, in any of the sciences, because there is where you're dealing with a lot of either very large or very small numbers, and exponents are very useful for showing numbers that are really big or really small. So we're going to look at one where it's a little bit bigger. It says a band of cumulus clouds is located at 10 to the 4th feet, 10 to the 4th power feet. A commercial jet is traveling at 38,000 feet. What's the difference between the altitude of the clouds and the altitude of the jets? So I've got my, let's draw it out. I've got my jet Okay, up in the sky, it tells us that it's at 38,000 feet, and we've got the clouds. Okay, and it says the clouds are at 10 to the fourth power feet. So before you can find the difference between these two, you've got to ask yourself, what is 10 to the fourth power? So expand it out. 10 times 10 times 10 times 10. And then just break it down. 10 times 10 is 100. And times 10 times 10 is 100. 100 times 100, 10,000. So the clouds are at 10,000 feet. The commercial jet is at 38,000 feet, so it's above the clouds. What's the difference in altitude between the two? Difference. Keyword there tells me I'm going to subtract the two. So 38,000 feet minus 10,000 feet. The difference is 28,000 feet. And that's that. All right, so if you need extra practice with this, take a little time to watch this as many times as you need, and also feel free to ask me for some extra practice problems and I can provide those for you. But good luck and do your best.